Now what will happen? Covalency, you can see, as I told you, the number of electrons shared by an atom of non-metal, shared by an atom of non-metal is called its covalency. And what is the force here holding? So there also I forgot to say that. In electrovalency, the force which is sharing by them, that is what making them together, the bond which we used to call it as here, please note it everybody, ionic bond. What is the bond name, everyone? Everyone? Ionic bond. Okay, because ions are forming here. Now here by sharing, so that the force by which these atoms are held together is called covalent bond. So whenever you get a covalency, what is the bond present between them by sharing of electrons? Everybody? Covalent bond, which to says. Clear? And by donating and receiving electrons, what is the bond which says? Everybody?
Ionic bond.
Ionic. Okay. So that is what. Now, let us make the example, everybody. So we all knows that oxygen molecule. Oxygen is oxygen molecule. It is what is the atomicity oxygen? Monoatomic or diatomic? Everybody? Oxygen molecule. Everybody? Oxygen molecule. Sir, why sir oxygen atom cannot be existed? So it cannot be. Oxygen molecule is O2. So why? What is the valency of oxygen? Valency of oxygen is, atomic number is how much, Amma? 8. So atomic number is 8 means, so what is the electronic configuration? Solunga everybody. K and L, 2, 6. 2, 2, 6. Do you all understand everybody? So what will happen?
Yes.
Nucleus, you can take it. So first shell, how many electrons are first shell?
2.
How many electrons in first shell? Speak loudly, everybody. 2 electrons. Okay. Now how many electrons in second shell? How many electrons in second shell?
6 electrons.
6 electrons. So to become stable in nature, how many electrons it needs in valence shell? 3, 4, 5, 6. So to become stable in nature, how many electrons it needs, guys? Everybody? Yes, please. 2 electrons it needs. So that is what? So one oxygen atom combined with another oxygen atom. So how far it is, you can see. So that atom, okay. So this is one oxygen atom and this is another oxygen atom. So here also it is there. So valence shell 1. So another shell I am drawing. So please adjust and draw. So this is what? So here they will share the 4 electrons. So here 2 electrons is present. For this also 2 electrons is present. Over. Now here shared electrons, sharing, or you can say shared electrons. Shared electrons. How many totally? 2 plus 2. Totally how many they will share? 4. Okay. So remaining how many? 6 correct totally. So 2, 3, 4. And here 1, 2, 3, 4. Now only you see one atom. How many electrons appears? Outermost shell. Only one atom if you see. 4 plus 4, 8. Only this atom you see 4 plus 4, 8. Like that, they will feel that both are having the 8 electrons and they'll become stable in nature. Do you all understand, Amma? Please respond, everybody. Yes? All of you? What? Respond. Any doubt? Please ask me. So everybody feels. So like this oxygen atom feels that, yes, I have 8 electrons. That oxygen atom also feels, yes, I have 8 electrons. So both become stable in nature. So that's what O2 molecule will form. That is what you have to remember. Clear, Mr. Lingesh? Any doubt, please let me know. All of you understand, Amma?
Yes, sir.
So please make it. Any doubt, please let me know. Okay. So this is what we used to call. This is what actually oxygen atom. And this is what actually oxygen. What is that, everybody? Oxygen molecule. Clear everyone? Understand? So please make it. Okay? Clear, am I everybody? All of you? Yeah. So this is what you have to remember. Okay? Next. There is another thing. You might be noticed in our textbook, phosphorus. All of you check it. What is phosphorus? Have you checked it? Even you also see that phosphorus valency, two are there. Have you noticed that? 3 and 5, two are there. Have you checked it, all of you? Yes, please. Valency, check it, everybody. Phosphorus alone, you have written 3 or 4. Am I right, guys? Yes or no?
Yes, sir.
Yeah. So that is the valency which we used to call it as variable valency. What we used to call? That valency we used to say is variable valency. So that is you will learn in actually 10th class also it won't come. So 10th class also very simple it will come. So like 1 or 2, but 11th and all you will get many things. Next, zero valency. So zero valency, it is very simple. Zero valency means what? How many electrons in its valence shell? Directly you know already. How many electrons in its valence shell? Zero valency. 8. That is what. Right. The elements which have 8 electrons in their valence shell and they do not take part in chemical reaction. Okay, everyone? So write it. All of you clear?
Sir.
Yes.
Sir, then in KSL, if an element has two
That is
electrons,
that is also accepted. The element, suppose if you take helium, only K shell, it has only 2 electrons, then also it is accepted.
it comes under zero valency, no,
Yes,
sir?
yes. That is also comes under zero valence.
Yes, sir.
Yes. Do you understand, everybody? Yes.
Yes, sir.
Yeah. Do it. Any doubt, please let me know. Okay. So zero valence means right. The elements, which have, my only K shell is there, that is also which have 8 electrons in their valence shell. In their valence shell. Do you understand, Sam? In the valence shell have zero valency and they will react in chemical reaction or they do not, everybody. They do not take part in chemical reaction. They do not take part in chemical reaction. So they are only call it as basically zero group elements. What is to call them, everyone? Zero group elements, or we can say inert gases, or we can say noble gases, or we can say unreactive gases, or we can say stable gases. Please note it. All the things speaks same. Inert gases, zero group elements, everything is same thing only. Hope you all understanding. Clear, everybody?
Yes.
Yeah. Any doubt, please let me know. Clear, all of you? Yes, please. Okay. So now variable valency. So we'll finish it. Variable valency also. So right. Some elements can show more than one valency. Some elements can show more than 10th class will get iron basically. Iron is one of the most important thing we will experience it. So that's what we will say. Okay. Clear everyone? Iron.
Yes, sir.
So some elements can show more than one valency. One valency. Right. These elements can have their valency equal to the number of valence electrons, equal to the number of valence electrons. Clear everyone? So that is what. So what is the, for example, if you have been taken. So if you take copper. So copper can shows basically either +1 or +2. Iron can shows valency of +2 or +3. So like that you can remember iron, Fe. Iron can shows like that. Some elements shows. Do you all understand everyone? So variable valencies, that is what you have to remember. So their valencies equals to their valence electrons. So if you come to here, so like if you go to class 11, so you will learn many things about this one. So if you even if you try to learn now, it will be leads to big confusion. So no need. Just remember, major valencies are two types. One is electrovalency, another one is what? Everybody. One is electrovalency, another one is covalency. And zero valency, we need to learn. But coming to the variable valency, so it is only when you are practicing, like we can say higher classes when you go, so there only we will come. Clear everybody? Okay, everyone. So this is what is all about that. Then tomorrow we are going to see calculation of the valency, formation of ions and calculation of their valencies. Okay. So that is what cations and their valencies, anions and their valencies. What is the importance and the characteristics? That is all we are going to finish in tomorrow's. And then numericals based upon this. After that, last concept, that is what isotopes and isobars. So very, very important. So this is all about this chapter. So please work out with this. We'll end and tomorrow we'll meet tomorrow. Thank you, everybody. We'll meet tomorrow. We'll